Okay, thank you, Chris. Thank you, everybody, for coming on. So today's presentation is a hands-on, well, not your hands, mine, but a hands-on how to use our most basic software system, which is CommunicatorPQA. So to give you a little bit of a history, our company is Electro Industries. We're 50 years in the business of digital meters. We've been making software for configuring and measurement for a very long time. And this presentation is going to have three parts in it. The first part is going to be how to sign on to this to a meter and how to view real-time data. The second part is how to configure the programmable settings. And the third part is going to be how to view logs. So we're going to spend some time on each of them. Now, CommunicatorPQA is our most basic software. It comes in two modes. It comes in a light mode, which is what I'm showing you here, and it comes in a pro mode. And in a pro mode, it adds what they call meter data management. Meter data management allows you to not just talk to one meter at a time, but to manage a fleet of meters. Our meter data management tool is called Meter Manager, and we will be going into it in detail in our next webinar. That Meter Manager is right here. And when you see how much easier it is to manage fleets of meters with Meter Manager, you'll see why there's two differences. So the basic purpose of CommunicatorPQA itself is really configuration and viewing some basic logs. Okay, so I'm going to start. Now, our third level of software is a product called Energy PQA. I did a webinar for you last week on Energy PQA. And Energy PQA is our cloud-based energy management system that takes data collected from Communicator and Meter Manager that's pushed up to the cloud for you to do data analytics, AI, predictions, view screens, a whole bunch of visualization. So that's the next level up of our software using Meter Manager. And you can see through Meter Manager, it's much simpler to do. And you can see now we're connected, and it will show us in our device stats which meter we are, the boot, the runtime, the ASIC, the run mode, vSwitch, and on-time data. All of this is available on at the device status button. So what you have now is you're connected to a meter. It tells you on the bottom what your IP address is, the name of the meter, Modbus TCP, whether the passwords are enabled or disabled, then the TCP IP connection. Over here, you get to view the real-time readings. So here's your real-time readings: voltage, current, real power, reactive power, apparent power. All the different basic readings you would find on the meter. You can see the frequency to the 0.001 hertz. You could also change this to a spectrum and see a spectrum analysis. Over here, you have the energy. So you can look at the energy, demand, min demand, phase A, phase B, phase C, and total. Here's your energy: received energy, delivered energy, net energy, and total energy. And you can see we're doing it through each phase. Over here is your harmonic spectrum. So these are what we call your greatest hits. Your greatest hits of readings. Of course, you could look at a spectrum analysis. You can have a spectral analysis of the THD or a waveform, actual view oscilloscope of the waveform. Here's your B phase, your C phase, your A phase, your B phase. You can see the harmonics here are much higher, and you can see that in your THD reading and your TDD. And you go right over here, you see your spectral analysis. And that's it. Very nice, very simple, right? Here's your phasor diagram. And this is a three-phase system, a delta, this is a Y system. And we have a lagging, two phases are lagging, one phase is leading. And you could see the different, although they're saying 2 phases is leading and 1 phase is lagging, but that's a programmable setting. That's not how you do that. And you could see here in options, you could set what you want it to be counterclockwise. You could set vectors, you could set triangles, or you could set vectors and triangles. Generally, I like vectors, but I'll show you what it looks like. It's just a different presentation in the options section. But the more typical one is the counterclockwise. So you see here, it's a counterclockwise rotation, which is more typical. So now you can see the leading current, lagging current, and leading current and lagging current. Leading, lagging, and leading. It tells you what it is. If you want to take a picture of it, you can make a copy of it, bring it into Word. Make a blank document. Bring it right into it. So you can see it's very simple, very easy to use. So far, we haven't done any of the menus. We're just going down the toolbar right here. This meter doesn't have flicker. If it did have flicker, it would have it right there. And log statistics. This shows you all the different logs in the meter, and you could pick which one of these different logs you want to download from. And to download a log, you would just pick this and press retrieve. But we're not going to do that yet. Device status, I just showed you. And alarms. If there's anything out of alarm, it will tell you what your alarms are set, what the value is, whether it's in or out of that alarm. Here's the set points, and here is the status. So you can see very clearly where we're at right now. Okay. Other real-time readings are all right here. Instantaneous polling, I showed you. Max-min readings. You can look at your max-min readings in real time. You can see when your max-min happened from the last time it was reset. All the data is available right here. And then you have a bunch more in multiple devices. If you have more than one device on the circuit, you could actually do a little comparison here with multiple devices. It's more for a debug tool than it is for, really using whole screen. And uncompensated readings. These are all uncompensated readings if you put on loss compensation. So you can see here in the real-time readings, you have a choice of a few different things. In the energy readings, you have your power demand and energy, energy in the interval, and pulse accumulations. Let's look at power demand and energy. So here's your power demand. This was a Shark 200 meter. So it gives you the VA, the watts, the VARs, and the power factor. And it gives you the max demand and the min demand. And it shows you again, the energy received and totaled. This shows you demand for each of the phases. So what we showed you before was the total. Now this is each phase broken down. Energy interval, and this just shows you what energy in the interval accumulation is going on. Again, this is good for troubleshooting. And if I'm going too fast, this is all very basic, so just chat to go over something. And this one is showing you accumulators. So these meters have the ability to count pulses, right? So what do you count a pulse from? Well, you can count a pulse from other meters. You can count a pulse from water meters, from gas meters, from electric meters, from steam meters. Once you have that pulse coming into the meter, it'll display what the scaled value is and what the unscaled input is, the raw input and the scaled input. And in the programmable settings, you can choose to do that. The next list of stuff is we have our power quality and alarms. So we're going to look here at the phasers. We did that already. We can then go over here to the harmonics, which we did. And the other one is the symmetrical components. And you can see here, it'll display its symmetrical components in real time. positive, negative, and zero sequence data. Another one is the input status on this meter could be used for either counting pulses or as a status detect. So if it's set to a pulse, it'll count pulses. If it's set to a status detect, it'll show you here the current status, whether it's red, whether it's, and you just saw it's actually a pulse, but you'll see the status, and you see it blinking here periodically as it's pulling it. You'll see it just, that's each pulse coming into it. See them coming in and blinking. Right, so we just went through symmetrical digital inputs. Now I'm going to show you limits. So this is your limit screen. And you can see here, I showed you it before. Again, the above set point, the below set point, whether it's in or out of status and where we're at. Again, copy it, right? Everything is compatible. So let's put it in. And goes right as a CSV. That's okay. Okay. Power quality, real-time trends. If you have a Shark 100 meter that does not have trending, you could actually have this software do a little bit basic SCADA trending on it. You would set it over here. You'd make the poll interval, let's say 1 second, and then it would start it, and it will start polling and bringing data in. So this is very nice for meters that don't have data logging. If you just want to trend it over an hour, or over a day, something like that. However, I highly recommend using log data as opposed to real-time trends, because if the computer freezes up or you lose the connection, you lose the trending. With log data, you never lose the trending. If the meter is working at all, it's going to record its data.
Aaron, if I could jump in, David has a question. He's asking, polarity for VARs, is it showing leading versus lagging?
Yes.
Thank you.
Yes, it'll show you leading versus lagging on the bars. Yes. Energy demand. So it's showing here, not on this screen though. It's showing you on the VAR hours, the received and delivered, and it actually makes a plus or a minus sign for leading and lagging on this meter. On the 270, it actually tells you lead and lag at the same time. But here, where you can see here, we have a negative sign, and here's your lagging demand on the VARs. It's a negative sign.
Great, thank you.
Any other questions?
Yes, we do have one more. Can you view the scaled and unscaled pulse counts in light mode, or is it only available in the pro mode?
Okay, everything I'm showing you right now, other than the meter manager, is in light mode. So you can view these in light mode. But the meter manager, as you saw right now, for some reason it didn't store. I should have put it in the I don't have the light mode has a phone book that the one doesn't, but oh, it does. It has the Connect Manager. There's a simple phone book which I should have set up for the meeting, but the meter manager is the better way to to look at it. So I just exit it out. So yeah, so everything I'm showing you is in the light mode. Nothing I'm showing you is in the pro mode except for the meter manager, which will be next week.
Great, thank you. And again, if anyone else has a question, please look at the Q&A button at the bottom of the toolbar.
And I find it very difficult myself to remember all the IP addresses, so which is why I use the meter manager also for that purpose. Okay, so you press the profile right here, and that's how you program. You see, again, everything's on the toolbar. Let me exit out of this word file. Just minimize. Everything is on the toolbar, so you can see all your data right there on the toolbar. So you don't have to grab it again right there. And you could go right in here and you could look at everything for programming the meter. Now, you can see here, retrieve logs, open logs, everything is right there on the toolbar. If you're connected to Energy PQA, this will turn green and it'll tell you that you're connected and that you're pushing. So the first thing we're going to do is the CT and PT ratios. Here's my CT numerator is 400. My CT secondary is 5. And here's your multiplier. On this meter, if you could, you could do as many, it could scale to anything, but most people will scale it 1. And you can also make it a ratio, 80-to-1 ratio. So you have a choice of which way you want to go. You could pick the ratio, or you could do the CT numerator and denominator. Different people look at it differently. The PT numerator is the same thing. So let's say we're at 138,000 volts. You can make it 138,138. But there you can see, because this is an LED-based meter, we can't put the full in. So you can multiply, make it 13.8. 100 is 138,000 volts. 138 to 120 times 100, or you can put in the ratio. I can update the ratio. You could set the meter. Do you want it to be a Y, a delta, or a 2.5 element? And you could set here the minimum threshold. The minimum threshold is the zeroing out. So sometimes the meter is very sensitive, and sometimes it may see signal at the very low end, just being picked up from the air, from the line. So you can put in a threshold as to where the pickup, minimum voltage pickup is, so that when there's 0 voltage, it really shows 0. I think that's real important because it's scary when they see a small voltage. Time settings. You can have here time settings. You can enable daylight savings. You can disable daylight savings. And you could pick when you want the daylight savings to occur. You can also set here your Greenwich Mean Time, right? We're -5 hours. And here you can enable clock syncs. Different meters have different levels of clock sync, but this meter has, you say yes, NTP or line frequency. So we can enable it to line frequency. And here, what's your frequency? Is it 60 or 50 hertz? 60 hertz. If you wanted to do NTP, you press the NTP, and they just got to pick. It says that's where your Ethernet card is, and then you press yes. System settings, require password for resetting items, require password and you could just change what that password is. And communications, very simple. This is the front port communication. This is the COM port 2, right? The serial port. Serial port can be Modbus RTU, Modbus ASCII, or DNP3. So we'll pick Modbus RTU. You can set the baud rate. See, the baud rate's all programmable, down to 1200 baud, but we'll set it to 57.6 is nice, but we can set it to 9600. And the other thing you can have is a response delay. And this is very important to know. When you're dealing with serial communications, we set it default to a 0 response delay. However, sometimes you might have a 45 to USB or a 45 to 232 converter that's not fast enough to turn over the bus. And that causes a little bit of delay, right? So you can actually put a response delay right here of 50 or 100 milliseconds, so that when you're talking on the serial port, there's time for it to transmit. It's transmitting the data, and it's got to flip the bus, and it's listening for, to send out the, then it's back to receive, then it's somebody else who's transmitting, and it's switching back and forth. Sometimes you need a little bit of a delay there to allow the 45 to 232 converters or to USB converters to flip. Our Unicom 2500 actually has a little microprocessor in it that's listening to the end of the message and flipping it for you, so you can have a much shorter response delay. But the standard ones that you buy, from distribution, they're not great with this. So you may want to put this. So if for some reason your 45 is not working, that might be a place to look. And it's always a good first place I start with debugging. When it comes to RS-45, it's very easy to wire RS-45, but at the same time, it's also complicated, right? So you got to make sure you follow the wiring instructions, you wire it properly so that it works. Then after that, what you want to do is you want to make sure that you deal with this response delay to make it work properly. And that's how I feel about it. Our manuals actually describe this very well and are very easy to follow. Now you have a choice here. You can have your DNP options, voltage, current, and power in secondary, or you can have them in primary, and you can have the divisor here. Now we could spend the whole time talking about how to program the meter for DNP, how to program the meter for all this stuff. I'm not going to cover the details on the DNP in this webinar because it could occupy a lot of time. I know there's some of our utility customers online, and we could set up a separate webinar just for that if anybody has questions. So if you do have an interest in that, please don't hesitate to just chat it up that we might be interested in that, and we will set it up for you. So here you have your DNP settings. All right, display configuration. This happens to be our Shark 200 meter, which is an LED-based meter. So you can pick here, do you want to make it a single phase display, two-phase display, or three-phase display? Do you want it to auto scroll or not auto scroll? Voltage, line to neutral, line to line, amps, watt var power factor, watt var, var hour, VA hertz, and watt hour. Now you can have the power direction viewed as load. In other words, in an LED-based meter, we indicate delivered energy. It could be positive or it could be negative. So the question is, do we make the positive as load or do we make the positive as a generator? And you have a choice here, which one you want it to be. Most industrial customers, the positive is a load. Most of our utility power gen customers, the positive is what they send out, what they deliver is positive. The reverse would be what they receive, which is only when the power plant is not running. Again, if you want to change the power factor sign, you can do that here. So leading and lagging, what's the designation? You could change the current auto scale. Do you want the current to auto scale or do you want it not to auto scale? Most people will actually set this to off because if you have a 400:5 or an 800:5 ratio, you really don't need an auto scaling current. Display voltage in secondary. This is for some of our utility customers who want to look at power and amps in primary, but voltage in secondary. So here we have that feature. And this is, do we use the IEEE IEC power coordinate system, their methodology? And the answer is yes or no. Or the standard one that comes in the Shark. This is all described in the instruction manual for the Shark 200. And you can look up which methodology works best for your application. The other thing that's on a Shark 200 meter is a load bar. And you could tell it, okay, what is 100% of the load bar? And 0 is 0. So you could say 400%. But if you're really if you're on a 400:5 CT, but your max you're ever going to see is 200 amps, then you would just set this to 200 and it would say 100% at 200 amps and it would go to overrange at above 200 amps. Enable a fixed scale for the voltage. The voltage defaults in most of our meters as a auto scaling event. Above 10,000 volts, it scales to the next level. So it'll be 0 to 9,999 volts will be just volts. Then it'll go from 10,000 to 100,000, it'll be kV. And then from 100,000 up, it'll auto scale again. This usually works for people because voltage isn't really variable, right? It doesn't really move around. And you don't sit at a steady state voltage that's low, in most cases. However, if you would like to fix that, you could fix it here, and then you could just tell it what it should be. So let's say you're at 10 kV to 99 point something kV, right? 99.99 kV. So let's say if for some reason it drops to 7 kV, it'll stay on kV. So most people set this to auto scale. Some of our customers want it not to auto scale. It's up to you. Now, if you look at the settings here, they're set by general settings, revenue and energy, power quality alarm settings, trending profiles, and option codes. So we designed the product to be very much by subject matter. So if you have the right subject matter, revenue and energy, all the settings for that will be in that section. And that's what we're going to do next.
Aaron, if I could jump in, we do have a couple of questions.
Yeah.
The first one, David is asking, sorry if this was stated before, but what is the resolution of an event in the logged data?
A resolution of the event in the log data?
Or he clarifies, what is the duration of a loggable detectable event?
Oh, that's a good question. So our meter has two separate logging areas, and it depends on which meter you buy. The historical trending profiles, the lowest resolution we have on a Shark meter is 1 minute. On Nexus meters, it's 1 second for logging. On the power quality resolution, the shortest duration on a Shark meter is, I believe, 30 kilohertz. On a Nexus meter, it could be up to 50 megahertz for recording an event. So it depends on the meter you buy, and different meters have different functionality. And basically it works like this. The Shark meters, whether it's a 250 or in this case a 200 meter, they will generally log all the trending log applications you need. Plus, they'll give you some power quality recording. The Nexus meters are really made for power quality primarily. And so they're much better at logging power quality records. And they'll give you shorter durations, they'll give you more functionality, better settings, and stuff like that. And we could set up a call just in that area, webinar for describing it. There's a lot to cover, so I'm trying to go like a little bit greatest hits on a general purpose call, but we could spend quite a bit of time on that. So is there another question, Chris?
Yes, we got a couple more. So the last part of David's question is, can you please expand on how multiple meters are time synced with each other?
Okay, that's a good question also. So the time syncing, the way it works in meters or in any device really is you're time synced to a standard, right? So you can time sync to a number of different ways. This Shark 200 meter gives you two time syncs. It gives you NTP to an NTP network time protocol, right? So it gives it to a time server that's on the internet or on the network, on your network, dedicated time server, or it'll synchronize to the line frequency. So what does that mean? Line frequency is the actual cycles of frequency coming in on the power line. Now, the law is this, that utilities in general have to provide you 60.0000 hertz at the end of a month, right? So they can go a little faster, they can go a little slower, but they have to count up all their frequency cycles and provide you a normalized frequency at the end of the month. And the reason is left over from the old time clocks, the old IBM mechanical clocks that you would plug into the electric. They would, if we didn't align the frequency, the AC motors in them would be a mess, right? Your clocks would be constantly needing to be readjusted. They would go fast, they would go slow, and it would change around. So there's a lot of rules on making clocks accurate, and that comes from the power line. That same method of synchronizing those clocks we use also. And by the way, it's not just us. Anybody who does anything with a time clock generally will use that. If you don't have NTP, and if you disable the time synchronization from the line frequency because your frequency is not stable or it runs fast or it's not predictable, then it will use its internal crystal to time sync, the standard that's internal in the meter. So the meter on a Shark 200 has a 20 part per million crystal. On a Shark 250, it has a 3.5 ppm crystal. On the all the Nexus meters is a 3.5 ppm crystal. So, and ppm is parts per million. So on a Shark, it's about 30 seconds a month on internal crystal. On a Nexus or a Shark 250 or 270, they are about 6 seconds a month accurate. They're much, much more accurate. It's a much better time reference in the higher end products. So these are the kind of choices that you have in terms of time synchronization. Now, Nexus meters also provide DNP time syncs, so do Shark 250s and 270s, and IRIG-B time syncs, and Nexus 1500 Plus provides PTP, IEEE 1588 time sync also. So we could spend a lot of time on this, but there's a lot to cover in a little bit of time. But those are different standards for time synchronization. IRIG-B based on a GPS satellite clock that might be installed in a substation, and PTP is a very high speed another internet or Ethernet time sync protocol that's very high speed. So we have those protocols in the higher end of the meters, and it depends on your application, what you really need. We have a bunch of sales engineers and support engineers that can help you define your application as far as which one you need. My default is always to try to go with the Shark 200 or 270 or 250 and build from there if you need it. My view on the business is always use the most cost-effective product you can use that will do the job for you. And if you can't, then we'll sell you the more the more featured products. Chris, any more?
Great, thank you. Yes, we do have a couple more. Regarding the PT ratio settings, should it be hooked up line to line, line to neutral, or base?
So basically, you're setting this line to neutral. You're setting this line to neutral. If you're in a Delta system, right, then you would have to set it to. It's recommended you change the VA computation, but the vector sum. Okay, it's giving you a little more than that. Right, then you would set it to, let's say, a whatever 208 system. So yeah, so you would set it there, but in a Y system, you're setting line to neutral.
Great, thank you. Next question is, so we were talking about the delays for what is the best way to determine the required delay?
Okay, that's a good question on the communications, right? What we covered here.
Yeah.
So what I do, and this is, RS-45 and timing is sometimes more of a art than a science. I always go with 100 millisecond delay. Always will set up 100 millisecond delay. And if it's a Unicom, I'll set it to 0. If for some reason it's a long run and it's a high baud rate, then I might set it to 50. If it's any other 45 converter, I'll set it to 100 millisecond delay right off the bat.
Great, thank you.
That's my standard troubleshooting, and I would recommend that to our support engineers also.
Great, thank you. And the last question I have for now from George is, could the meter be used to monitor a motor in rush current?
Yes, the Shark 200 meter is not the motor in rush current product that we have, but all our Nexus products that will work for, especially the 1500 plus, which would be the ideal product for that.
Again, thank you. That's all the questions we have for now.
Okay, great. And keep them coming because that's the point of this webinar. Okay, so revenue and energy. So we talked about that you can have energy scalings here. So here we have to set our energy data. On this meter, the energy data is fixed. So all of the watt hour, bar hour, VA hour are all scaled the same. On our 250, 270 products, you can individually scale them. On our 1500 or any Nexus product, you can individually set them. So here we'll set it, let's say, to 8 digits, and we'll set the decimal point to 3 or 2, how many places you want it to be set to. And this shows you the scale. Do you want it to be watt hours, kilowatt hours, or megawatt hours, right? Megawatts. So generally, kilowatt is the most common. On a utility, you might go with megawatt hour. Now, this is the scaling. Do you want to auto scale it or do you want to fix it? Just like we did with the voltage. Generally, people set this to auto scale, but but you could set it to a fixed scale because this way it doesn't make changes to the readings if the load is low and you're going through that transition point. All right, it wants it set to auto right now because I set it up here to auto. Now, apparent power VA calculation method, you have your choice on this meter, a vector sum or arithmetic sum. And basically, it's just a different way of calculating the VA. and you could pick which one you want to use. I personally always use the vectorial sum, which is the calculation we use in the Nexus meters, default. But we also support an arithmetic sum. VA, there's different ways of calculating VA. Arithmetic being the simple one, right? Which is the voltage plus current A, voltage plus current B, voltage plus current C, add them all up, and voltage times current, I mean, voltage times current, voltage times current. Add them all up and you get the arithmetic sum. Vectorial sum would be the square root of the watt squared plus the var squared. Would be the vectorial sum. Okay, demand averaging. You could set it to a block demand or a rolling demand. When you set it to a rolling demand, it gives you the sub-intervals. 15 minutes, and you could have, let's say, 3 sub-intervals. I would set this to 5, and that's your 15-minute interval window with 3 5-minute sub-intervals. And the next thing I'm going to talk about is transformer loss. You have percent loss of watts, percent loss of vars. You can enable or disable it for, for ferrous, for iron only, for copper only, or for both, right? Most people use both. And then if you press this button here, they give you a little time of use calculator. And in this time of use transformer loss calculator, you can do system losses. And you just enter the data, transformer losses. Anything that's in the light blue is a data entry point. And you get this information right off of the nameplate or the test data of the transformers that you're using, the power transformer. So if anybody doesn't know what transformer loss compensation is, transformer loss compensation allows you to meter on the secondary side of a power transformer. So if I'm a utility and I'm bringing in a main feed of 14,000 volts to a big industrial manufacturer, well, I'm going to put a big power transformer there. And my power transformer is going to step that 14,000 volts down to, let's say, 277, 480. And at 277, 480, I'm going to feed it into the building. Okay, that's great. The utility would rather meter, and you would rather meter on the secondary side of that transformer, not on the primary. The reason being is, on the primary side of the transformer, to put PTs and CTs, it's very, very expensive, right? So each on a 14,000 volt medium voltage, low end medium voltage transformer, it could be $2,000 each sensor. You need 6 of them. On the secondary side of the transformer, $100 each sensor, and you need 6 of them. So it's really a lot more cost effective to meter on the secondary side of that transformer. However, there's losses in that transformer. That transformer will generate heat. It'll have losses, and as a result, the utilities have developed a structure to be able to calculate what those losses are and kind of bump up the energy a little bit to account for them. In that area, this is how you do it. You could do the transformer losses right here. And on that transformer, they tell you the information right here, and you just put it in. And then over here on the line losses is the other thing. So if you're transmitting power, right, you're going to have losses on that line itself, and you could add those line losses into here, right here, line current, all that kind of stuff. So you have transformer losses, you have line losses, which results in a total system loss. And in that total system loss, you put it in here. It will then generate the numbers, the calculation numbers that you put here, and then you take those calculation numbers and you put them right into this section here, and you have all the compensation done. And that's how this works. I'm not going to cover exactly how to set it up, but that could be a separate webinar onto its own. But I just wanted to show you that this is the area where you would do it. This is available on all our Shark series meters, Shark 200, 250, 270. It's available on our ST40 meter, and it's also available on every Nexus meter we have. Any questions before I go to the next section?
No questions at the moment. Again, if you do have a question, at the bottom toolbar, you'll see the Q&A chat box. Thank you.
Okay, trending profiles. So you can see here we have the trending profiles. Here's the first profile, second profile, and third profile. So we have 3 separate data logs on this meter. On our Nexus series, there's generally between 6 and 8 trending profiles. Shark 250, 270 has 6 also. So this one has 3. And you can see here, these are the options that you have. It's separated by group. And you can pick each group, what you want to log. There's a million things you can log. And then over here is what you've actually set to be. So this one is set for energy in the interval watt hours, energy in the interval var hours, negative var hours, energy in the interval VA hours, and your 4 pulses. That's on log 1. If I wanted to add, let's say, voltage to this, you just add the voltage. And you can see it tells you, based on the way I set this, I have 71 days of logging at 15 minutes. Obviously, if you set this to 1 minute, you'll only have 4 days of logging. So you have to adjust the memory. I'll show you how to do that. The second one, well, I'll do it now. You go here to the historical log sectors and you say, okay, how much data do I want to assign to each of these logs? And you could just move it around. So let's say I want to take away from the waveform log a little bit, put a little more into the historical logs. And you can log it. It tells you how much data is set up, and then it shows you how many days of logging you're going to get per log. So in its current configuration right now, based on the settings that we changed, we have 142 days of logging of these data. So you can see, and this is our lowest end meter, right? This is our Shark 200 meter. It's funny, we're customers. This actually monitors our manufacturing. So we use the Shark 200 as our base meter in our facility. I just because it's been there a long time. But it's a very useful piece of equipment because it does have, even in the low memory version of the 200, quite a few days of logging that you can set into it. Now you go to the next profile, you can set something totally different. Like this one is looking at watts, bars, VA, power factor, demand, voltage, current, frequency. And you see I have the voltage here, so it doesn't make sense to really set it twice the log because you're logging the same parameter. So it's logged here, so we'll just have it stay there. And in the historical profile 3, we're logging our THDs and our energy, not energy in the interval, but the actual energy itself. So all of this data is being logged. We have 155 days of logging at 15 minutes. And you can see here, it's showing you how many captures of waveforms. So if I want more waveform captures, maybe I'll cut some of this memory out. Now I have 34 records I can capture. And the PPQ log is set at 3,000. You don't really need that many. 1,000 is more than enough. So you can see here, the meter will capture 38 waveforms, 38 events until it FIFOs. And it has give or take about 100 days of logging of each of the logs that we just set up. And you can see you could just adjust it to your need. On our higher end meters, there's 6 of these logs and you make the same adjustments. But there's more memory, so it's a lot deeper what you can record. But you can see this is still quite a bit. Now, Meter Manager, that will, again, not for today's discussion, Meter Manager automatically collects this data. We have this set up to collect, I think, once a day. So you only need a day's worth of data, but it will be stored there if for some reason the computer goes down, or you're not using Meter Manager. You're only going to get to the meter once a month, or you want to look at it on an as-needed basis. So this is how your historical trend profiles work.
Aaron, we have a question with regards to capturing events. What period constitutes a waveform capture event?
Okay, so the waveform capture, which I didn't show you, so I skipped over it, so I'm going to go back to it. The waveform capture is a 1-cycle event, and it's updated every half cycle in half cycle increments, right? So it's moving boom, 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 boom through it, updating half a cycle. So if it affects the RMS of a cycle of data updated every half cycle, then it'll trigger an event. And that's generally considered a half cycle update. And you can see here, I could ask you to do it. Now on the Nexus meters, on the Nexus 1500 plus, it has what they call a transient feature. And that transient feature says if any value is, any one sample is above our capture or below, our capture then record the waveform of that section. That's called a transient value. And that is up to almost 1 million samples a cycle. Any one of those cycles is above, boom. Any one of those samples in that cycle is above, it captures it. On the Shark series meters, it does 512 samples a cycle peak, and it cycles through a half cycle updated window. And you can see here, here's our full scale. Here's our primary. So I can set this to go 20% above full scale or 80% below full scale for a setting. Now, one of the things you'll notice with this meter is you don't need to set it. It is in most cases already pre-configured to record waveforms properly. You do not need to set it. In addition to that, the trending profiles default that ship with the meter are triggered to record almost everything you need right off the bat at 15-minute intervals, and they're all pre-configured to work directly with Energy PQA without anybody setting it up. So we went through all of this stuff, but the main thing you're really going to find yourself setting when you actually go to use it is the CT ratios. Right here, the CT-PT ratios. We can't pre-configure that for you, so you have to set it. And in your networking, your IP address. And this is the IP address from this meter. So you could see those are the two things you're going to have to configure. They're the only things in the meter that you are probably not set to your need. Everything else will be automatic. But let's go back to the waveform. So this is what the default setting is: 120% above, 80% below, or below 80%, above 120%, below 80%, and the current is only above 120%. So if you're 120% above the 5 amp secondary, it's going to record. Here is where you could set your sampling rate. You go up to 512 samples a cycle. Generally, honestly, I believe 128 is adequate. And then you can write what the pre and post waveform is. So we're going to set this to 3 cycles pre. And that will be your capture. And then once that's captured, that'll store it in the meter's memory. When the meter manager, or if you do it manually with the free software and you download the data, then it will push that data up to Energy PQA, and you'll view all the data on Energy PQA. And again, we went through this. Limits, it's the same thing. So limits are preset: voltage, frequency. Now, some of the limits we can't set for you. So some of those you have to set. Like if you want to do a power setting, if your watt total is above 110% of full scale, right? You may want to set a setting on that. You may not want to set a setting on that. So this stuff, the voltage and frequency, we default because we know what you want, but we don't know what you want here. So you have to decide what you want to set here. And you can set these limits above and below. And you can see, and it tells you here what all the full scales are. Okay. Now I'm going to hop down to the network settings. And you can see here, here's what the computer name would be. The name for that, it's called, I don't want to change it because we're using this meter as part of our energy management system here in the company. So I don't want to change it, but you can use DHCP here, where it'll automatically assign an IP address, or you could use an IP address here, and put what they call a static IP address. And here's your domain name servers, your DNS servers, and here over here is your source file name. If you have an NTP clock sync, you would put the clock time in there. And we'll talk about this in a second. Chris, before I go on, any questions?
No, none at the moment. Thank you.
Okay, great. So here allows you to turn on and off service. So we just showed you how to program the IP address. This shows you how to turn on and off services. So we have a web server that can respond to HTTP requests. You can put the web server on port 502, on port 80, or you can put it on anything else. Our Nexus series meters allow you to do HTTPS web servers. The Shark meters don't have that, although we're coming out with it for Shark meters. enable Modbus TCP, allows you to use Modbus TCP or not use Modbus TCP. And if you're not wanting these features on your meter for security reasons, you can just shut them off. And I think that's a very nice feature, to be able to just shut off the services you're not using. And basically it's like having a little router in the meter. And our higher end meters, they have more settings, but every feature we give you can be disabled on the network card so that nobody can hack in through a backwards port. Our network cards are all done here. They're homegrown. They're not off the shelf items. So we have designed them to be secure right from the get-go. And that's why there's been very few breaches or hacks or anything on our equipment, because we are in complete control of the network connectivity on the products. And the silent mode, again, this is a network security feature. An exclusive client, right? If your network firmware supports this, if it's the latest shipping, is it will only respond to this IP address and to this MAC address. So if you need really high security, you could say this is the only server. Meter manager is going to be here polling it, right? Nothing else is collecting the data. Just respond to that IP address and MAC address. And unless it sees that IP address, it won't respond. It'll just stay silent. And then DNP support, again, enable DNP. You can put in where the addresses are, or you can disable DNP. And you can see very nicely that we can enable or disable everything that the meter is doing. And the pulse outputs right here, this is what's connected, allows you to set, okay, this is a positive watt hour to it, output ID, and the output label. Now, this could be anything you want it to be. This is if you want the pulse output. This is output pulses, what we're sending out. Any of the energy values we read, it could take, and you could just set what your pulse count you want it to be. And you can label it here. You can just label it anything you want it to be. And over here is digital inputs. And you have an accumulator. You could set the digital inputs. Digital inputs are physical inputs that come into the meter that are digital, not analog. Analog inputs are voltage, current, power readings. Analog is just, is it on, is it off, status detects. So you could set them to an accumulator. You could set them to an end of interval pulse. You could set them to a digital input log, and you could set them for status only. So you could pick any one of them. You could say trigger it on a change when it closes, or not. Well, this one is status only, so we have to set it to whether it's a change or a closing. So you could set it to whatever you want it to be. Digital input log is on a change. Accumulator could be, move up when you're accumulating, opening. And then we also have this feature for high-speed opening and closing. High-speed opening and closing is for gas and water meters. So over here, we have a pretty solid debouncing algorithm that when it sees the detector come in, we debounce it. But on water meters that are coming in very fast, we have to tighten up that debouncing, because you could be getting 100 pulses a second, 200 pulses a second. So we have a high-speed one where it has less aggressive debouncing on it. And again, units per count, compression. So if you might say my one count is 1 kilogallon, right? But for every 200 pulses, you see, it's going to be 1 kilogallon, and that's what the compression does. And then this is the labeling, and this is the inputs labeling. So if you're getting an input, what's the open state, what's the closed state, and you can label it here. All of this labeling and all of these settings will push into Communicator, into Log Viewer, where it'll show you what it is, and that will push it up into Energy PQA, which will then give you all those kinds of details. So this is the basic settings, and we're right at the 1 hour mark, which was my goals, to get it through it in 1 hour. These are the basic settings. There are a couple of things on the revenue meters that we could still show you, which is how to program custom displays, how to program time of use settings, and I think that's it for the revenue meters and how to put it in test mode and upload energy presets. We're going to set that for a separate webinar also, because I think that might kill our whole hour. So the next thing I wanted to do is set up for you is, so you want to exit. I'm not uploading this, which I'll just show you how you do it. You can update the device right here. You're about to update programmables. You want to update it? I'm going to say no, because it will update the programmable settings. I don't want it to. You could save this profile here and just store it as a, test profile. You could load an existing profile if you wanted to, and then just make the changes to that existing profile. And we have all our default profiles right here. So you get the default, it comes with the install of the software. And you can just view a report, which will actually show you what all your settings are on that report. This one is in a text format, and you can see it right here. These are all your settings. You could print this report or save it as a file so you have all the settings saved and you know what you set the meter to. And then once you do that, you just update the device. And it says, you're sure you want to update the programmable settings? You say yes, and all the settings go up to the meter. So you can see here, it's pretty straightforward, right? General settings, revenue and energy settings, power quality and alarm settings, trending profiles, option cards, and that's it. And it's easy to set. And you can see we went through it in about an hour, with explanations. We tried to make it very straightforward to program and configure meters. That's it. So I'm going to exit the programmable settings section. So is there any more questions, Chris?
We have one. We may want to take this offline though, if it's too in depth. So Bob has a Shark 200 with a PO1S card installed as a 3-element Y in a 480 volt service with CT ratio of 600 to 5 and a PT of 120 to 120, both with multipliers as 1. Is there a maximum units count value that he can enter over the default 1.8? He's trying to see if he can set the value to provide 1 pulse per kilowatt hour.
Yeah, so there's a calculation you could do to do that. So what you're trying to do is you gotta really multiply it up to get the number. Off the top of my head, I forget how to do it, but if we'll do this offline. Is this Bob our Bob?
No.
Oh, this is one of our customers. Yeah. You got to multiply by the CT ratio and then take the ratio down to the secondary of the pulse. And it ends up being a 0.0000 something pulse setting to set to that. But I don't have it in front of me. So we can take that offline and we'll show you how to do it. We do it for customers all the time.
Great. Thank you, Bob. I'm going to send you an email and I'll copy our engineering services team as well. And then Charles is just asking, yes, we will have this session on our YouTube channel within the next couple of days. As soon as we finish the recording, we'll get it up there.
Yeah, and we have actually versions of this already up on our YouTube channel.
We do.
This is just a refresher course. Okay, the next thing you want to do is retrieve logs. You can see here, profile. Remember, we went to all this stuff. Profile, retrieve logs, open logs, and then connect manager, which I'll show you. So I'm going to retrieve a log. So you can go over here. This shows you all the logs and all the data in the logs. You can press what data you want to retrieve, and it'll start retrieving the logs. Let's say we do a retrieve. It's going to start bringing the data down. And you see it gave you a list, historical 1, 2, 3, 4, 5. And now it's bringing this data down to the meter, to the software, and it's pushing that data into the database. And I'm just doing one of the logs right now because I don't want to, it takes time to take all the logs. Especially since I haven't downloaded this in a while because I use it primarily energy PQA at this point. Now it's downloading the system events logs. So system events logs are interesting. They tell you everything done with the meter. It's an anti-tampering log, and it tells you everything done with the meter. It's not resettable. It's not you can't muck with it. There's no programmable settings on it. So if anything is done to the meter that doesn't look normal, it'll be right there. You can see here in the lower right, it's converting all these logs from a binary file, which is how we store it in a binary format, and it's sending it into a database. Once it's done doing this on a manual retrieval, like I just did, it's going to load up Log Viewer, which is the log viewing package. Give me a second. And Log Viewer is loading up right now. So here you have Log Viewer. Here's 1,700 chains. So we're going to spend now some time on Log Viewer. But before I hop off to Log Viewer, I just wanted to show you the rest of this retrieve logs. So retrieve log, you press the button right here, and you could just pick any one of these to retrieve. So you can pick any one. You set it for partial retrieval, or you could set it for a time-based retrieval. I always use partial retrieval, always. And the reason why is partial retrieval is intelligent. It looks at your database, it says, I have data until yesterday, then it goes from yesterday to now and collects the rest of the data. When you use a time use data, you might get the last week of data, but then it won't go back and fill in data on partial retrieval that's before that time. So I prefer, unless you have a bandwidth issue or some sort of problem with downloading, I would just always use partial retrieval. It's always better. And you could pick your 3 historical logs, your alarm log, which is any limit you set is right here, system events, IO changes, status changes, relay changes, a power quality, and waveform. You just pick whichever ones you want, and then you can just retrieve them. Like you can see, we just retrieved historical log 1. So when we go to retrieve it, it always downloads the programmable settings to see if there's been a change. And it's going to start downloading. Obviously, it was just done, so it just pops in and out, and you can see how it works. And what is it logging? It's logging. Right now, it's doing a little conversion because it's converting just the fact that we attempted a download. So if you just go quickly into system events, let it load up. It shows that we just did log retrieval just a couple seconds ago. But I don't want to be on this yet. I want to finish up with the rest of the stuff. So you can see here all the different logs. That's how you retrieve a log. And by the way, in log status, it's the same screen at this point, log status. Some of our meters have a separate log status, but on the Sharks series, the buttons are just the same. You can open a log. Now, if you have Meter Manager installed, it brings up this kind of snazzy log, which it looks at all the meters and embeds Meter Manager on this to figure it out. And then here it is, right? If you don't have it, you will get this. And you just got to pick which database you want to pick to look at, right? Each one of these is its own database. Every meter has its own database. You can pick which database you want. Meter Manager, it makes it easier. Here's this meter right here, but we can look at the log of any meter, really, anything that's on this. That's it. Now we wanted to look at this. We could open this one up. And I'm not going to do that. So that's your open log. Connect Manager allows you to make like a little address book, which I should have done, which you put right here. You put the IP address, the network port, and if you have a data switch, you put it here. Then you save that. So this one, let's say Electro Industries, and I use my Nexus meter, right? .com. I don't think I need to put .com. Put .com or 502, and then I just add it, right? And then I have this set up right there. If I want to make a different meter, I can make it defaults to a 1250 meter, but make it be any Nexus series meters. 100 series. We can store it right here. But That being said and done, I prefer not to use this. This is an older method, and we only left it here for our legacy customers that have had very big connection managers that they've built over the years. This is not a currently supported feature. The better way of doing it is to go here to the button to the right and do the meter manager button. A meter manager, it loads up meter manager. Just give me a second. Oh, it's right here. It comes up right here. So this is the better way to look at this. And this is just a link button to this meter manager page. Meter manager not only shows you what meters you have, but if they're online or offline, it's going through and it's polling them, it's checking them, it tells you what firmware versions you have, the next time it's going to download. It does the full meter management of the meter. So once you get on Meter Manager, you really never go back to Communicator. Communicator standalone is okay if you want to program a meter, but if you really want to use it as a system, it's a mandatory Meter Manager. So so that's where we're at here. So now I'm going to look at the log viewer. So the log viewer application, I have 2 copies of, gives you an idea of everything that's going on in the meter's logs. So Meter Manager or Communicator standalone will download logs stored in the meter. And now this allows you to view those logs. And you can see over here, system events, it was the first one I showed you. So system events shows you everything here. Anytime somebody downloads, log retrieval is the most common thing you can see. So anytime somebody downloads something, you can see what it is. You could sort them in descending or ascending order. Here's an alarm, an IO change, PQ event. Basically, anything that happened with the meter is logged in this system events log. There was a password failure. If there was an unsolicited attempt, everything is logged right there. Well, I popped out. Just let it load. Okay, the next thing you have here is database status. Now the database status shows you that this is a Shark 200 meter, the name, and it shows you when's the first bit of data that's in the database, the last bit of data that's in the database. It shows you how many days of data you have, stuff like that. Right, and then here's the time range. So you could pick, okay, I want to look at it during the previous 1 year. That's pretty good, right? Or you could have it during the previous 2 years or during the previous month, hour, day. I always use a year. Now you pick the historical trend. Now this is all the data that we stored. If I showed you earlier in those 3 logs, this is all the data that was stored in those 3 logs. So there's 31 data points here. And we could bring in, you could select it, you know, like this, and then add it out over, or you could do one at a time. Once you have this data here, then you press OK. And it automatically takes those points that you chose, it digs into the database. And it makes a database, it makes a file. Now you could select this like this. You could press Control-C, load up Excel. Right, and then you go Control-V, and it puts all the data in the database in Excel. Took my limit data. But why didn't it take That's it. Apologize. I did Control C, but it wants it to do this. And then here's all the data that you have right there in Excel. Now, Meter Manager has the ability to not only do this in Excel, but has the ability to generate custom reports that will automatically get emailed to you with any data you want, and not just on one meter, on all the meters, if you want to look at it. So, but this is very basic. If you want to bring it into Excel and you want to bring the data into Excel, take a look at it. You have it right here. You can adjust this. And then here you want to just change the time format. Dates. It gives you all the date and time. And you could save this as a file. And this is the data that's stored in the data file. So you can see it's fully compatible with, like I said, the free one allows you to do this. The paid for one allows you to make automatic reports that you can use. We have reporting both in Energy Reporter, in Meter Manager, and in Energy PQA. The best reporting package we have right now is in Energy PQA. It's the most configurable, and you could set up hundreds of reports generated for all kinds of purposes. But if we want to graph this in Log Viewer, we go over here to Graph. Let's say we want to do our watt, our var, and our VA. And then we just write Advanced Graph. And we have the graphing right here. Now, this is set for a year of graphing, but we could default it to a month. You could zoom on it. And it shows you everything about the data. Again, this is the free package. It's very simple. You can look at anything you want to look at with it. And you can bring back any data you want to bring back. What's nice about this, it has some cute things about it. One of them is, you can set the colors, you can set the scale, you can actually adjust things around. Oops, I did too much adjustment. Right, but it also, you can play with the vertical scale. You can edit it, and you can change what the colors are. But you can also do the max min. You see, look at this. This is nice. It shows you on this graph that you set up when your max was and your min was for these channels, and what your average reading is. So it has this like little tools in it that I think are quite nice. And if you wanted to export it, you just export it right here. Make a bitmap out of it. Then you bring it into Word. It comes right into Word. Or maybe I should have used PowerPoint. Any Microsoft product will work. So you can see here, you have this nice charting and graphing, very simple, very easy to use. Does anybody have any questions on because I'll do it a little bit slower, but you press here the button. And the trend comes right up. Anybody have any questions, Chris?
Yep, we have a question with regards to the system events log. So if there is a change in the device profile by someone or a new profile downloaded at some point, is that captured by the system events log?
Yes, in every meter we made. So if anybody tries to do a password change, a new profile especially, a demand reset, an energy reset, any changes to the meter, anytime somebody communicates with the meter and does an action, download a log, upload a profile, reset anything, it's all logged in system events. It tells you what IP address it came in on. It tells you everything about it. It's fully secure for that purpose.
Great, thank you.
And this is our 200. Our 1500s give you even more, our Nexus series gives you even more data. Yeah. Is there another question, Chris?
No, that's all the questions at the moment.
Perfect. Okay. So next thing we go to is we're going to look at the waveform recorder. In the waveform recorder, it shows you very nicely here your voltage sags and surges that you had on the line. Now, if you want to graph them, you can graph them, but let me go first to the power quality recorder. The power quality record takes all these waveforms and kind of organizes them in a Sabima graph. So you can go over here, and it shows you in a Sabima graph what data you have for the period, right? And you can see here how long the event lasted. You can make some adjustments to this section here. Well, it doesn't have more data to make adjustments. So you click over here on it, and it tells you the time and date and duration of the event, right? And you can see that on the Sabima graph, right? And it's pretty nice. If you want to change this to a semi F47 graph, you can change it to a semi F47 graph. If you want to change it to a histogram, you can change it to a histogram. Shows you what is the histogram. Okay, I went a little quickly. Let's go back. This is Sabima. This is the Computer Business Administration, Computer Electric Manufacturers Association. What these guys do is they look at what type of events affect you in a negative way, right? In other words, if you have an event here, it's a very high speed event, even if it goes high in above full scale on the voltage, this is only voltage, right? It doesn't have a big effect because not much energy in that event. However, if you come over here to a sag, everything below here is a sag. And this sag over here goes to 50% and it lasted for, whatever, 3 seconds, 4 seconds, 10 seconds, right? That's a problem. This is a 10-second event. So it lasts for 10 seconds. That's a problem to computers. It's the same thing up here. And there's a competing standard called semi F47 that's basically doing the same thing. If your duration is long and you're below a certain amount, it looks at it and tells you that this is a damaging event, right? This is for the electronics industry, the microchip industry, and this is for the computer industry. In addition, you can look at it in a histogram, which just shows you how many events you had at each dip. And there's only 2 events in this record. So that's why it's showing you these 2. Just going to cancel out of this. Now, what we could do is we could say, let's say we had a sag event, right? And we want to look at this sag. Let's pick this guy. Just randomly pick one. You could press graph. Oh, you can show waveforms. If there's a waveform. And then you pick the event. Let's say, I want to pick a sag event. Let's try this one. This tells you, this is my sag event. This is my waveform trigger in that sag event. This was a C-phase sag. And you can click it. And it'll actually show you the events. You could see what the event is, right? And this triggered on a CN sag. So this little sag right here was the trigger, even though there was some other event going on here. This is what it triggered on for this event. So there was another event that would be the event above it that was probably referred to in this one. And you could zoom in on these. Let's say we want to look at this event and we want to look at the current. And you could take a look at them and look at them together. Let me double click it. And you can look at these together and see what the events look like. You could also do a waveform properties and it'll tell you what the settings are to the waveform. I'm sorry, I'm just looking over because I have the camera is blocking some of these buttons. And you could, let me go back into that event. You could take a look at this event. It'll automatically give you an RMS trend for that event. You can look at the waveform details. It'll do a cycle by cycle harmonics for that event. Show the RMS, the block, the peak, the crest factor, percent THD, and it'll go through it cycle by cycle. So it does give you a full amount of waveform records. See, here is a nice little sag. And you could actually zoom in on this. There's all these like little advanced tricks here. And here's the RMS trend, and you could right click on this. Let's say we want to click here on when the event trigger happened. And you can put an annotation. You can add a note. That talks about it, right? And, or you could change it, you know, that's not a great note, right? So we'll put it to a voltage. And then what you could do is you could also take your ranges. And you can have 178 milliseconds in that range. It shows, and these annotations are stored in the database. So if you go out and you come back in, you will have this, you know, data analysis that you did stored in the range. Of course, you can export it. You could bring it into PowerPoint or anything like that to take a look at it if you want to show it to somebody. And again, everything I'm showing you is the free software. You know, the meter manager is not the free software, but this is all part of Communicator Live. The other things you can do is just looked at waveform. We looked at power quality. We don't have any control outputs or status, so it comes up a gray. That just means that they aren't enabled. If you want to press an out of limit, it'll look at all the different limits, but it didn't seem to find any limits for this time period.
Aaron, can you show how a user would view the system logs?
Hey, you just press the button right here.
Thank you.
And it all comes in right here. All of these are available not only here in Communicator, but they're available in Energy PQA also. You can see everything in Energy PQA. And you can see it's mostly because this meter gets retrieved from a lot. But you can see here an IO change, PQ event, you know, system events, historical log. Anytime it's doing anything, it just tells you. Even when it writes to its own system events, it tells you that it wrote it. You can just bring this into Excel. You can sort it. You could, you know, do what you want with it to try to like go through it. It's very detailed.
Aaron, we have a question. Is it possible to compare two waveforms on the same screen from meter 1 and meter 2?
Yes. Sorry, I exited out again. Let me just get back in. Yes, that is possible. It's called advanced waveform. It was the thing I was going to next. Let's go to view meter logs. Give me 1 second. So if you go here to the waveform, and I want to look at, let's say, this waveform, you double click on it. It shows you this waveform event. This is a tiny little voltage sag right here. Then you go to advanced waveform. And you say in advanced waveform, I want this voltage AN, I want this voltage BN, and I want this voltage CN, right? And then you press, you could graph it, or you could go back. It stores it in the buffer. So now what you do is you exit out of this, right? And you exit out of log viewer. Let's just go to a different random meter. Let me pick, I'll do this Shark 200. We're going to open the meter, view the meter log. Give it a second to load. And then I'll go over here to the waveform, right? Now you can see I want to then pull this waveform graph. Let's say I want to pull this one, right? Double click on this. I go to advanced waveform, right? And I pull this in. And I press graph, and they should all be there. It's not there. Should all be there. So why is it not there? Oh, maybe I'm not allowed to exit out. Okay, so let's okay. Let's exit out of that. So you got to go over here and you got to change the meter here. It's pulling in. I just open a log file. I'm trying to find that other meter. No, let's see it here. Pick a open log file. For some reason, it's not opening it. So I'm gonna have to cancel out. But generally, you would try to put that second meter here to do that, but it doesn't seem to capture it from what I'm seeing. Oh, because that meter wasn't live. That's the reason. Okay, so I have here. So now I go back to the waveform, and it should work. I pressed the wrong one. I apologize. Yeah, there it is. Okay. And you add it here. Apologize, it's been a while since I've done it. That's the advanced waveform, but here we go. And you can see here, you can line up the different waveform captures from the different meters. So you can see here we have the VA, VB, VN, VN. You could do up to 6 channels, and you could do, they could be 6 channels from different meters, 6 channels from the same meter. They could be at different meters at different times. It's all doable. So it's just a matter of just going through the steps to do it. And that's how the waveform recorder works. If you're using the meter with PQ diff, you would press this button here and our system will automatically create PQ diff files. It's not programmed to do it here, but if it was, it would do it right there. And ComTrade is the same thing. If it's automatically making ComTrade, this is configured to make ComTrade files and they would be right here. I don't have a ComTrade viewer. If you have flicker data, like this meter now has flicker data, it would actually show you the flicker, max min, and all the details on flicker. For those that don't know what flicker is, flicker actually measures the light flicker on your eyes when the power system isn't stable. But I don't have it in the time range that we picked, but if we had it, it would come up right here. It measures the flicker in the time range, measures the light flicker on your eyes. And there actually was a study done in the 1970s where they figured out how much of that instability in the voltage magnitude is annoying to people. And it's based on incandescent lights, but that's how it works. And interestingly enough, if you have a number 1 or less, nobody sees the flicker. If you have a number 1 or more, everybody sees the flicker. So if you have a meter that measures flicker, like most of our Nexus meters do, they'll actually give you that designation. You could log it and you put it into the logs and you can record data on it. So this is the kind of stuff that you can get with Log Viewer. If you're using Nexus meters, you can also get some power quality reports that are automatically generated. And this is what you would get in addition to the flicker. You'll get the reports on harmonics, voltage sag surge, short interruptions, long interruptions, and data like that. And we could cover that. That's a detailed meeting on its own. So I just want to stop right here. I want to take a couple of answers and questions because I went through a lot of material. If you just don't mind, let's go over it.
No questions at the moment. Again, if you do have a question, if you look at the toolbar at the bottom of your screen, you'll see the Q&A chat box. Just click on that and send your question over.
Okay. The other things that you're going to find here that we just wanted to cover before we end is all the tools related to the meters, right? Edit current device profile is the same as this. Change V switch. So the way Nexus meters work, Shark meters work, Nexus 2, is they have these things called virtual switches. And the virtual switches allow you to upgrade functionality in the meter, even after it's installed. You take the serial number, you send it to the technical support, you give them a credit card, they give you an upgrade number, and you put that upgrade number right here. And then it upgrades the meter, adds waveform recording to it, adds more advanced functionality. Set the device time. So right now you can see the meter is set, it's 11:36. It's actually pretty good. So you don't have to set it, it's showing you what the time is, but you would set you could set it right there. So tools is very helpful. You can retrieve meter device time. You can see it's right there, actually could be used to be set. So we're going to do a setting. Let's see if I have set device time. I was afraid of that. Could be confusing. I don't have the password for this, but I would set it there if I had it. And reset device information. So if you want to reset your logs, your max min, your energy, anything you want to reset, you could reset right here. Obviously, you need a password to do that. So if I try to reset it, are you sure you want to reset this information? It's going to ask me for the password, which I don't have. So, and they'll kill me if I reset it because we use this for our energy management system. So, device information. So device information is again, device stats, that's right there. It's the same reading. Very good because it shows you the firmware version, the time. Option card information. Each option card has its own serial number, hardware version, software, boot firmware, runtime firmware. Each one has it. So we designated here. So you could look it up. If technical support calls and say, okay, what's your firmware for your network card for this meter? Right, and then I'm just going down the list showing you relay control. If I manually want to trip the relays, I would do it there, but this meter doesn't have it. Meter firmware update, this is how you go to update a firmware. You get what you call a .s file, .shark file, and you would select it. We give you this file, and you can just start upgrading the firmware. And basically firmware, for meters in warranty, which is 4 years, firmware is free. You get the firmware for free. And a lot of times meters out of warranty, firmware is free also. Technically we charge, but we haven't really charged anybody. So we give you the firmware for free. We do not post firmware on the internet. We do not post firmware on the internet, even behind a password and sign-on. We don't want people readily having copies of the firmware. We don't want reverse engineering of our code. So basically, we vet who you are, whether you actually bought a product from us, before we send you firmware. So There's a little bit of security in that, but generally it's readily available. Each firmware works for all the series of products to the extent of that hardware version. And if you put it in right here, you put in the file and it starts the flash process. Again, this is the same thing, but for the network card. It's the same thing, but for the network card. And network card, manual waveform capture. So if you want to capture a waveform in real time, hey, I don't like the way the system is right now, just press this. It'll ask you for a password because it's a control event. And if your password clears, you will get a manual waveform recorded. CTPT compensation factors. Now, this meter, the Shark 200 and most of our meters, okay, right? It tells you that you've set it to 60 Hertz. So this is what we're using as our default frequency. This is where you can actually program to compensate the meter to make it more accurate for CT and PT ratios, right? CT and PT ratios. Not transformers, not ratios, transformers. So if I have a current transformer and I want to set that tighter and calibrate it, well, I can get those factors off of it right here and put that in. You can write the factors from the device. You can read factors from the device. Utility companies use this. Most industrial commercial customers don't. It's available in all our Shark, higher end Shark meters, Shark 270, 250, 200, every Nexus meter we've ever made. These are precision instruments and we allow you to calibrate the sensors that are feeding the data to. Network card status. This is just a status screen telling you everything is running well with the network card, that it was able to reach stuff. Low level access. This is just a debug. You know, when you're having problems reading, apologize for that. When you're having problems reading from the meter, we'll ask you to use this low level access. It's a debug tool. Shows you what the communication traffic is going on it. And send the meter restart command. If for some reason you want to do a soft reset on a meter, you go there, you would select that and you would press restart and it would send the soft restart. And that's in a nutshell what the tools do on these meters. The tools are very useful. You use this a lot for doing stuff. Log statistics we covered, retrieve from device we covered, a log database. If you want to archive your logs, you got to put a new source file name, a destination directory, a destination file. So the source file name would be one of the DB files, right? So we would pick, let's say, this DB file. And then you want to select database to archive, right? We selected it. There's no database there, of course. But you got to pick one of these that has a database. So let's try this one. That's right in there. Then you type in your destination, you put in your file name of what it is, and it'll archive all the data beyond a certain time. Meter command, logs, and view. And this allows you to just launch Energy PQA. So if you click this button, it will take you to Energy PQA. And it'll log in, but I don't think I am logged into Energy PQA. So. And these are your options. So in this options, just a little slow, but it loaded it. In your options, you could say where you want the files to be stored. The data scan mode, you could set it to a normal scan rate, which is as fast as it comes, or you could set it to a custom scan rate in milliseconds. Some people want slower scan rates. Tech mode options. So we have a tech mode capability, which is something for our support team. And if you enter into tech mode, we show you a bunch of stuff that's like not done yet, or we're still working on, and stuff like that. So, you know, you don't need to be in tech mode unless we put you there. Retrieve log, it just gives you some data attributes on retrieving logs. These are just miscellaneous settings. Again, packet delays, timeouts, whether you want it to be in Spanish or English on the network card. And here we have also Chinese on this in the meter. These are the default languages we support. And this allows you just some special settings to the 1262.72 meter. And that's in a nutshell it. If you ever get lost, right, you can go to our website here. You can check for software updates here. So it'll actually go and check for an update. However, to get an update, you must have the licensed version. The free version does not have updates. End user license agreement, software license. And if you click here, it'll actually load up a full instruction manual. Eventually, it's a big file. And so that, in a nutshell, is the software. That's how it works. This was our basic training for communicator software. So I'm willing to take some more, my Adobe Acrobat's. I'm willing to take some more questions if anybody has any.
Aaron, great. Thank you very much for your time. So before we jump into questions, a couple quick announcements. So our next session will be Meter Manager. That will be next Thursday, the 24th of February. You can find the sign up link for that webinar on the website. A couple of people have asked if this is being recorded and available. Yes, it is. It's been recorded. It will be available in the next couple of days on our YouTube channel, which is Electro IG. And again, one last time, if you have any questions, you'll see the Q&A chat box at the bottom of the screen. And we do have one question. They are asking, if I purchase Energy PQA, do I need to purchase Communicator PQA separately?
Oh, great question. So if you purchase Energy PQA, you get our full suite of software. You get Energy PQA, the cloud package. You get Meter Manager, which we're going to show you next week. Luna Kovel, who's the senior developer and the inspiration behind Meter Manager. She developed all of the architecture for Meter Manager, is going to be hosting the call. You also get our Energy Reporter, which is our energy billing software, and you get Communicator. Everything comes with Energy PQA automatically. So
great, thank you. And I do have one last question. How does Communicator licensing work? Do you receive one license for everybody to use or multiple logins per each license?
All right, so that's a good question. So Energy PQA licensing with Meter Manager and Communicator works like this. You pay per meter. So if you have 10 meters, if you have 100 meters, they calculate a price for you at the cost of a year. It's a SaaS base. And you can install the software freely anywhere in the world, as many licenses as you want. With the professional version, if you buy it standalone, it's one license per Meter Manager, per event. So you can always use the free communicators, but you buy per Meter Manager. So anytime you set up a server with a Meter Manager, that's a license. So it's one computer. Energy PQA is as many computers as you want all over the place. So it's more cost effective, actually, a lot of times to use Energy PQA than it is to buy the Pro software itself. The Pro software is a perpetual license, so it's more costly. Energy PQA is a one-year license, so it's less expensive. And you don't have to use Energy PQA to license it. You can buy Energy PQA and just use the Meter Manager portion. You'll get Energy PQA, and it's excellent, so I would consider using it. But you don't need to. So you could go either way, and the salesperson will advise you what's the more cost-effective solution.